Welcome everybody. Thank you for giving us some of your precious time. And Brian, thanks. I mean, it's been a joy working with these guys. I mean, the partnership that we have with Amazon is pretty amazing. And this is an interesting technology, and it's kind of a circle back for me, having spent previous evolutions in search, language processing, and AI and whatnot. So it's nice that it's all coalescing into the Amazon HealthLake. So I've been with SnapLogic about a little over 9 years now, had a variety of roles and responsibilities. And since I've been here a while and I've done a lot of different things, I'm fairly familiar with what it does, how it works, and what it can do and how it can be applied. So what I did as part of this conversation was I went out to the homepage for Amazon HealthLake, and this is a schematic or a graphic that they have on their page, and basically all I did was just insert SnapLogic into the appropriate places. As Brian mentioned, we're in the transportation business. You have data, you need to acquire it, you need to put it someplace, talk to us. We're the easiest way to acquire, transform, and deliver data. And the ability for us to extend our capabilities to support HealthLake was a function of creating a couple of snaps that were fire compliant, as far as not only the parser and the formatter, but also the infrastructure. Well, being on Amazon, we're already halfway there. The ability for us to create artifacts that are compliant with the standards. So you're going to use SnapLogic to acquire data from any endpoint and quickly, easily transform it into a fire compliant format that can be loaded either in bulk, in a streaming format, or in a triggered format through the REST API. So we can basically do any velocity of data into HealthLake in a compliant format. Now, once AWS has done their magic, and this is where, and having come from the search space and studied linguistics and such, the ontology and the mere trying to get data out of unstructured text when it has to do with medical terminology, especially random clinical notes, is one of the most challenging matrices that you can use out there, because you have chemical names, you have commercial names, you have compound names, you have all Latin, you have trademark names, and all of these are jumbled together into information that means something. And if you have the right ontology, you have the right approach, you can create models out of this that will allow you to get value, real insight into this clinical data that heretofore has you've been shut out of. Now, once it's been cooked and it's ready for consumption, obviously, Amazon has got SageMaker and QuickSight. But if you're, using something else as part of the equation, we can help you in terms of querying the data or sending it someplace else for participation in an environment. So at the 100,000 foot level, SnapLogic is a integration platform as a service, or a SaaS offering. And our goal is to simplify the acquisition, transformation, and delivery of data so that mere mortals can create these integrations, or pipelines, as we call them, that will allow them to connect to a source, whether that is an application, a file system, a database, or a protocol, an API, whatever it is out there. I tell customers, give me a port, give me a protocol, give me an IP address. I will quickly and easily connect to that endpoint, acquire that data, and allow the user to manipulate it and then deliver it to its target without writing a lot of code, using snaps to abstract the functionality, and then snap parameters to provide the details of, validate this, format this, convert that, encode this, decode that. So you're writing JavaScript expressions, not code, in SnapLogic to acquire, transform, and deliver data. So the value proposition of SnapLogic is we abstract the low-level functionality. We allow the user to focus on the functionality of the problem at hand and be able to get stuff done. So with that, I'm going to just jump into the designer. And SnapLogic is a low-code, no-code drag and drop environment that allows you to connect to an endpoint, process the data, and deliver it without writing a lot of code. So this is what I did as a practice to this session. So I'm just going to go ahead and delete it. We're going to build it from scratch. Now you'll see up here I have a series of tabs of the things that I'm going to show you as part of the demo, going in and putting data into HealthLake and whatnot. But let's start off with something a little simple. All right, because most of you have probably never seen SnapLogic before. So let's do the training wheels before we jump in. So a snap is a task-specific software component that abstracts the methods of connect, transform, deliver. So if we go down and we take a look at something like Redshift, which is a database, where are you? Right here. Okay, so you'll see here, oh, and to make life a little easier for everybody, let's do this because I know I have a large screen. So let's make things a little more legible. There we go. So in Redshift, you'll see here that we have snaps, bulk load, bulk upsert, execute, insert, lookup. So a snap provides a specific level of capability. If we go to an application API like Salesforce, you'll see here that we have all kinds of neat and wonderful little gadgets in here that we use to read, write, and otherwise to their API. Now, no integration platform can have dedicated connectors for everything under the sun as much as we'd like to. So we have protocol snaps and file systems that we use when we don't have a custom snap for an endpoint. So I can talk to any published API using SnapLogic. And because of the capability of the platform, when Amazon announced HealthLake, all we had to do was convert the HL7 parser and formatter that we had in stock to Fire compliant, and we were good to go. All right, so it was fairly straightforward for us to basically extend the capability to support that. That's why it happened so quickly. So let's build a simple little pipeline here in what I call the 2-minute drill. I'm going to go into Salesforce and I'm going to select an account. SnapLogic uses design time introspection to query the endpoint to determine, what availability the user has and all the typical things that we're used to in terms of, dynamic lookups and things like that. If I go in here and I click on this object here, it's now going out to the Salesforce instance and loading up all the objects that this user has access to. And of course, because there's thousands, I'm just going to go in and I'm going to grab my custom one here, and I'm going to make the pipeline self-documenting by converting it from function to task. So get students. Save. Now you'll see here a little gear is rotating up here in the toolbar with all the ubiquitous icons. All right, and if we're lucky, when we get back, there'll be a little data. So you'll notice it's also chromatic. All right, we have now a text icon that shows us that we have data to work with. No matter what format the data is at the source, as soon as it enters the SnapLogic universe, it is JSON. SnapLogic at its core is a loosely coupled streaming document engine that acquires a row of data from Oracle, an XML document, a SOAP message, something from Cassandra, goodness knows what we're going to get from Mongo. That comes into SnapLogic and poof, it's JSON. It's a string, it's a number, it's a date time. So SnapLogic is loosely coupled, loosely typed, all right? And that means that we are able to deal with the things that happen as things evolve. So now that I have the data, let's take a look at it in its native format. Now what I'm going to do is, just for a quick example, I'm going to write it to Redshift. So I'm going to go in here, excuse me, Redshift, and we're going to do an insert. Now I know if I was going to do anything big, I'll do it first. Now you'll notice that I've got a little ghost there because I need to relabel things before I put them in. Now in this case here, the same kind of design time introspection, I'm going into demo And I'm going into students with RUUID. Okay. Now, every place that you see a combination of an equal sign and a drop-down list box, that indicates that this value or this property of the snap is parameterizable. So SnapLogic makes extensive use of runtime or dynamic binding so that the same pipeline can handle 25 different use cases. So you're not building 100 pipelines to handle 100 use cases. You're building 9 pipelines that handle 100 use cases. This is the afterburner effect of SnapLogic. If you know what you're doing, you do it. It follows the programmer's one of the programmer's most oldest sayings: build it once, build it right, reuse it till you die. Okay, so that's the thing. It's like, just, build it right the first time, and then you never have to worry about it again. Okay, so in this case here, we're going to say insert students. Now we're going to go in here, and before we put it into the database, obviously we have to change the what it's called. So we're going to go in here and we're going to get the mapper, drag it over, snap together. So this is a complete pipeline or integration. Now, when I validate this, insert students and get students is going to be okay, but the mapper is going to come back and it's not going to be happy because I've left, basically, I haven't said anything. So I'm going to go ahead and I'm going to do an auto link. And this is a use of Iris, our AI initiative. Behind the scenes, she is looking at, and I personify it, sorry. She's looking at the input schema, the output schema, using, data types, type matching, all the rest of it, and also my use of the platform. And I'm going to accept all, and then I'm going to add a couple because it didn't pick up the, when I save this. Now you'll see here that some of them are bold and some of them are not, indicating what I've selected and what I haven't. All right, so you'll see here that I got almost all of them, so I have a missing one here. The pipeline RUID I'm going to put up in here, and what that is that's going to be the log, the instance of the pipeline's execution. So every pipeline that has ever run on the SnapLogic pipeline is logged with an RUUID. Oh, only one. Okay, the RUID is think of it as a GUID. All right, and so this provides some level of lineage. And so let's go ahead and save that. You'll see here that I'm down at the bottom. Oh, once this is finished validating, here's the before and here's the after. Now I also have the capabilities to selectively, if there's 50 fields, I only need to manipulate 3. I click on pass through and address 3, and everybody else passes through unchanged. If I don't click on pass through, then 50 come in and only 3 pass through. So that's obviously there. And because we're dealing in a JavaScript environment, certain data types, date time values, you know who you are, don't tolerate null values well, so we take care of that in line. So it's all about making it easier for the user to focus on the task at hand. So now I have a fully functioning pipeline which would load a row of data or a petabyte of data, simply reading it from Salesforce, mapping it accordingly, writing it to Redshift. How I accomplish this is as a triggered task, a scheduled job, or an always on listener or reader or consumer that would basically read messages as they arrive from, let's say, a streaming service like Kinesis or SNS or SMS. So let's take a look at our stuff specific to the HealthLake. In this case here, I'm using the REST snap to go out, and you'll see here I'm going against a public API, so I don't need to use an account, and I've just got a simple request, and I'm getting the pretty form of JSON, which, as you can see, is rendered here. I expand it all. So here is the request as it comes into SnapLogic. Now here in the JSON splitter, I am removing everything. All I want is the entry attribute. I'm removing a field. Here's a simple JavaScript expression that's manipulating an attribute of the payload. And finally, I'm posting it here to the HealthLake as a REST post. So this is an API insert a read from any third party or any other application using the REST GET and the REST POST to request and to send data into HealthLake using the REST Snap Packs. That is facilitated by our support for SG4. Okay. So now let's take a look at a little more complex version where what we're doing here is we're going out and we're reading a list file. So I've got a CSV that I've gotten from Epic. Okay, so in this case here, I'm dealing with Epic, but it could be Cerner or any other endpoint here. Because I'm any place in SnapLogic that you see a diamond, that indicates that you are dealing with binary data that has to be encoded or decoded from that format into a JSON document that is legible to the user and the designer. So a parser is on the way in and a formatter is on the way out. So we have parsers and formatters in the binary to handle a lot of these in terms of encryption and decryption, as well as file reading and writing and S3 and all the rest of it. And there's a few others floating around, but the binary format is what you're going to use to encode and decode. Now I can see what my payload is. So I've got a little sample file here. I'm going to sort it. I'm going to use this. I'm going to go to Epic, and I'm going to get a list of patients, passing it the query parameters of family and last name. I'm going to handle the array that I get back. I'm going to split it. So a lot of times what we're doing in these kinds of environments, ladies and gentlemen, is we've gotten a JSON document, we've got to take an array, turn it, pivot it, or we've got to stringify it, pull things out. So what you'll see in these kinds of pipelines in a production environment is you're getting a document, you're then walking through the array handling, stringify, hierarchical restructuring, basically to build the document that you can use to basically insert it into, in this case here, a database in Oracle. So obviously this has to be flattened out. And here you'll see in the mapper here, we're using a combination of static values and, well, in this case here, everything is an expression or a reference to an attribute, okay? So there's no static values in this one. So we're filtering the empty results. We're extracting the patient data. Oh, this is something that I inserted. All right. One of the things that SnapLogic does really well is masking or obfuscating data. Now, as I mentioned in the mapper snap, 50 fields come in and only 3 pass through. So you can prune cake. All right, and then poof, they're just gone. And because SnapLogic is a streaming engine that stores no data, okay, second rule, SnapLogic stores no customer data, end of line. All right, so everything is handled in a streaming environment. It's cached in memory. It's encoded or encrypted on the wire, and so as SnapLogic is executing its assigned tasks, we're doing this all pretty much in memory. So you'll see here in the mask snap, we have the ability to define policies, and you'll see here I'm just going in and I have access to all of the fields in the document, and I can do either an exact path or a recursive. And then I have a variety of options in here. Do I want to manipulate the key or the value? And what kind of match condition do I want to use? Is it a specific kind, or is this obfuscation, or what? I can add a pattern. I can add what value I want to work with, and the mask method that I'm going to use. So so SnapLogic makes it easy for the user to go in there and say, oh, I'm interested in gender and age, but I don't need to know, any of that other stuff. So it makes it extremely easy for the domain expert, for the clinical worker, literally as they're creating the records, as they're loading the data in, to make sure that what they're putting in there is going to be something that is going to enhance the model, not skew it. Okay, so this is an example here where we're doing a read of a file, we're doing a REST, we're doing a process, we're doing an insert into Oracle, we're then taking the results from that merge, we're doing another call to Epic, getting the medication order. We're then combining those in the FIR parser as a medication statement, formatting that. So the parser is what turns it into a FIRE compliant object type. So if we look here, you'll see these are all of the object types that are supported. Okay. And you'll see here also we have, the ability for, the version number. All right. So that's here. So this is what creates the binary FIRE compliant file, which is then dropped into Amazon HealthLake using the appropriate URL. All right. So this is the version that writes into HealthLake as either a triggered task or scheduled job. All right. Here's a version of it that would read a Confluent Kafka topic. And what you'll see here is that I basically extracted sections of this pipeline to build this one. Again, promoting the reuse of existing logic, being able to do it. Here's one where I'm getting some files from the what do you call it? This is the COVID one. Okay, so this is another example of reuse. 2 years ago, almost now, uh, uh, Patrick Taylor did a blog entry on how to acquire data that was published every day on COVID-19 data, and basically loading it into something like HealthLake or any other analytics platform. So this is a blog entry that Patrick did. I copied it and basically converted it to support Amazon HealthLake by just going in and changing the endpoint and the account. So you'll see here that this is again an example of the ease of use and the reuse of getting the data in. So we're getting the data in a triggered process, in a scheduled job, in a streaming version from Kafka, and we have support both for the file API as well as the REST get and the REST post. So we can insert data and pull data out. All right, so here's another example. On this one here, we're just doing a simple REST get for patient. And you'll see here, this was an example where I was showing the functions of the mask snap, where I went in here and I had someone, Sylvia Chalmers. And then after I applied the mask, Sylvia was now, yeah, blah, blah, blah. Okay, so just a quick little example. Again, this is one of those functional ones, just simple little exact path value. In this case here, I'm removing it. I'm removing the given name and randomizing the family name. Okay. Here's an example of doing a HealthLake query against my data store. So you'll see here that I have a live account, and again, I'm using the REST get snap to go out and pull FIRE compliant JSON documents out of HealthLake for consumption elsewhere. So you'll see here, and again, every place that you see these equal signs indicates that this is a parameterizable version. So for the solution that we're providing, all right, SnapLogic is a quick and easy way to be able to connect to a legacy system, pull that data in, and drop it into Amazon HealthLake, all right? But the value proposition so for HealthLake and Amazon, we provide or support user enablement. Industry analysts have been quoted as saying the adoption of SnapLogic as a platform is orders of magnitude over other platforms. Other technologies are used by a subset of individuals because, only 20 people can figure out how to get this thing to dance. SnapLogic is adopted by companies like Teva, like Bristol Myers Squibb, like T. Rowe Price, like SpaceX, and we don't have 20 users. We have 200. We don't have 100 users. We have 1,000 users at companies like Adobe. So, and when you have that number of people effectively accessing information, being able to do their jobs more efficiently, wonderful things happen. That's what we do. We enable people to be able to reach into the system, pull out the information. We allow them to focus on the what, while we handle the how under the covers. So for the corporation, for the healthcare provider, for the hospital, for the organization that's looking to run the operation, to run the business, profit or otherwise, it's all about connecting the systems and allow people to process orders, to order supplies, to be able to hire and transfer and pay people, the logistics of running a business. And if that business is healthcare, the stakes are very high. So you need high scalability, high reliability, and that's something we do. 3 of the 4 largest pharmaceutical companies on the planet use SnapLogic, all right, and they've used it for years. So our security and ability to conform to the highest levels of privacy and security standards, been there, done that. Here's an example of a reusable pipeline where a typical problem that people have in today's heterogeneous world is I've got an API and I've got a document that's coming in, and it's a hierarchy. It's like a purchase order or an invoice that has a header and a footer and then n number of line items. And while that's a piece of cake as a JSON document or an XML or an API request, to try and take that and put that into a table or a bunch of tables in Oracle or Snowflake or Redshift or anything else, let's just say it's not as simple as some people think if they're not using SnapLogic. If they're using SnapLogic, of course, it's a piece of cake. So what I'm doing here is an example. I'm just reading an order, a purchase order that has a header and n number of line items, and I'm simply doing a single insert for the header, and then I'm looping through the line items and splitting it on line items, and then inserting n number of line items into the child table or the line item table here in Redshift. So this is an example of how you'd have to struggle in or more primitive technologies to accomplish this kind of capability. In SnapLogic, it's a piece of cake. So with that, ladies and gentlemen, I'll stop and take a breath. Do we have any questions in the chat that I can answer? Teresa, anybody there?
Yes. Hey, Rich. We do have 2 questions. We only have 3 minutes, so we can address the first one quickly. Does SnapLogic provide a specific healthcare or connector for HealthLake?
No, it's just what we provide is the parser. The connection to HealthLake is through either the API, through the REST API, or through the S3 file reader and writer that we have. So the parser or the formatter that creates the FHIR document, that's the secret sauce. So so for us, that's I guess you would say that's the connector. That's the enabler.
Got it. Great. And second question, what's the value of data obfuscation?
Data obfuscation is limiting the if you don't need PII data for the model, get rid of it. Okay. And as analysts, financial AI or otherwise, when you look at the data, all right, there's certain conditions where you don't want to know ethnicity or gender or age. Sometimes it's important, sometimes it's not. So data obfuscation is done in some ways because that information is sensitive and shouldn't be looked at. So if you're taking information out of a clinical notes and you're putting it into a model, you're giving the individual the ability to say, this is relevant to the model or this is sensitive and I'm going to get rid of it. It's as simple as that.